So this is a question 11.61 from our book. So it asks, write a balanced equation to represent the complete combustion of each of the following. So the first example they give us is propane. So propane, if we're looking at, if we consider our IUPAC rules, so we're dealing with an alkane in this situation because of the ane, and it's not a cyclo, so we will be using the formula, our general formula of CnH2n plus 2. So now in terms of finding out our carbon, we want to look at the prop aspect. So that is 3 carbons. So we're going to have C3H8 is propane. And a complete combustion will always have with it oxygen. And our products will be CO2 plus water. Okay. So now that we've determined the chemical reaction, now we just need to balance each side. So I'm just going to take inventory of each side that we have. So I have 3 on my reactant side. I have 3 carbon. Okay. I have 8 hydrogen. And I have 2 oxygen. On my product side, I have 1 carbon, I have 2 hydrogen, and I have 3 oxygens. So the first thing that I'm going to do is I'm actually going to balance out my carbons. It doesn't really matter which one you balance out first, it all has to balance out. But I'm going to start with carbon and hydrogen because they're equal, they're easier factors to deal with than oxygen is with a 2-to-3 ratio. So we'll deal with oxygen, maybe it'll balance out as we go. So I'm going to add a 3 in front of my product side, So now I have 3 carbons. But of course that 3 applies to the oxygens as well. So 3 times 2 gives us the 6 oxygen plus the 1 from water. So now we have 7 oxygens. But we'll worry about oxygen later. So now I'm going to balance out my hydrogen. So I have 8 hydrogen on my reactant side, and I only have 2 on my product side. So I'm going to add a 4 in front of the only compound that has hydrogen in it in this equation, which is water. So that will give me the 8 hydrogen, and now I've got to recalculate the amount of oxygens I have. So if I have 3 carbon dioxide, that will give me 6 oxygen, and then the 4 oxygen from the water. So actually now I have 10 oxygen on my product side. Now this works really well because if on my my reactant side, I have 2 oxygens and I have 10 on my product side, 2 can easily go into 10 5 times. So I'm going to add a 5 in front of my oxygen gas, and that will now give me 10 oxygen. So now each side has 3 carbon, each side has 8 hydrogen, and each side has 10 oxygen. So a complete combustion reaction of propane would be C3H8 plus 5O2 will give us 3 CO2 plus 4 H2O. In another example in 11.61, question C, it actually gives us a structure to use. So in 11.61 C, we actually have a structure to work with. So we're given our square, so a butene, cyclobutene, with a methyl group, CH, the screen's hard to write on, attached to this side. So we have to use this in order to determine a complete combustion reaction. So because we're dealing with a cycloalkane in this situation, we have to our general formula